Hello everyone. This time we will present the final project of the Integrated Manufacturing System subject, and we are Berenice Rivera and Gustavo Hernandez.
The objective of this project is to apply the knowledge acquired throughout the course to develop a program that will follow a trajectory defined by us, following this process. First, we'll select the trajectory, then we'll do the target definition, then we'll do the programming on the Robot Studio software, and we'll simulate the program. If we were under normal conditions, we would do the robot calibration as well.
Some specification about this project is the type of robot that was the IRB 146 kg 0.81 meter. In addition, the MT02 Symmetrics tool was used, and three types of movement were used: Move L, Move J, and Move C. And finally, for the development and execution of the program, we used the Robot Studio version 6.10.02.00.
The objective of this project was to draw a figure on a plane with the following restrictions. The range of the robot in X is from 350 to 650. The range of the robot in Y is from -200 to 200. And finally, the height in C with the tool is 35 millimeters.
The trajectory that we choose is this, and we choose it because it has more than 50 points and more than 12 arcs. Furthermore, in this trajectory, it's not necessary to add a lot of approaching points, so we can save time making the drawing process.
To determine the number of possible points in the early stages of this project, we decided to use the software GeoGebra to calculate the exact coordinates of the points in the X and Y axis. Finally, we determined that the possible points were 83. And out of those 83, 21 were possible arcs. The figure was divided into two sections, so you could see the points more clearly. In the following slides, you'll see a close-up of both sections with the corresponding points in the Y and X axis.
As we can see in this image, we have the first part of the complete image. We can also observe the coordinated axis in the same way to define the work area. As you can see in this slide, we have the second section of the complete image, and also we have the working area.
As you can see in the image, every point is named with a letter. Later on in the table of coordinates, we will number each point to make it easier to program.
In this slide, we have the table of coordinates. In the first column, we have the points that are shown in the image. So this part is like C, D, E, F, G.
The second column, called Programming Points, shows an equivalence for the points mentioned earlier. For example, point C will be equal to point P10 in the Robot Studio program.
This is just the second part of the table of coordinates. So as we can see here, we have the complete table, and we have all the values to get the program.
The definition of these points is essential to ensure that we'll get the correct trajectory in the final product.
In this slide, you can see the programming code, but it's not the code complete. We have put only a representative image that shows the code, because the code is very large.
Now, we'll play the simulation for you to see the program in action. As you can see, the final product is very similar to the original picture. We faced different challenges in the programming. The first one was that we defined the wrong working area. We made a mistake choosing the X and Y axis. To fix this, we recomputed and reprogrammed the coordinates in GeoGebra. We also had trouble keeping up with the sequence of the point names in the software. For example, let's say you wanted to add an approaching point after P10. When selecting the movement you wanted, the point that would be added was point P20. We didn't want that, and we would have to modify the positions every time. So we decided to edit the main program in the rapid section, to delete and edit points from there. The final mistake we made happened when we were doing the table of coordinates. We got one of the point names wrong, and it caused problems for the other points. We used the same fix as the last problem. We renamed and rearranged the sequence of the points in the program to have it in the correct sequence to get the final figure.
These are only some recommendations. The first is that after defining the trajectory and the points, be very thorough when doing the table of coordinates because it will help later. The second one is that in the table of coordinates, mark the arcs so it's easier when doing the programming. Another one is that familiarizing yourself with the program before starting the project is very helpful. And finally, and it is really important, that pay attention to the coordinate system to determine the right working area and avoid making mistakes in the programming. It's important because if we don't determine the right working area, we can have problems.
After completing this project, we concluded that it's important to know this type of robots and their different applications in the industry. It's important to get experience and familiarize ourselves with this kind of software so that we can apply our knowledge in the future.
Being able to use the software to simulate the trajectory is very helpful since we can save money and other resources because of it. And finally, we think that the implementation of the internet and modern technology is the future of the industry. Understanding this is extremely relevant as industrial engineers.